Alright class, these are the homework questions that I've given you the last time, and I'm going to go through them now. Okay, so please take note of what I'm going to say. Alright, okay, now let's look at the first graph that we have. Y is equals to 4 to the power of x. Okay, y is equals to 4 to the power of x. So what we have is, it will go this way, cut at 1, and at point 1 here, it will be point 4 here. That means when x is 1, y is 4. That will be your first graph. Please check against your own answer. Okay, now for part B, it will go this way, because this is 1/3, which is less than 1. It will cut at 1, and when x is 1, it will be at 1/3. So please check your curve to see that it is the same. Okay, now next I'm going on to part C. Now part C is y equals to pi to the power of x. Now everybody knows that pi is about 3.142 and so on. So this is actually bigger than 1. So I will get this cut at 1. When x is 1, y is pi. Okay, now this will be the first 3 ABC that is given in your textbook itself. Alright, now I'm moving on to part D. Now part D says this: y equals to 6e to the power of x. Okay, e to the power of x. I already told you that e is a special value with 2.718 and so on and so forth. So you will go this way, but when x is 0, I will get 6, 1, that means 6. So it will cut at 6 and not 1. This is something that I want you to take note of. It will cut at 6 and not 1. Okay, and actually we have done this in your Emaths before. Alright, now next, let's take a look at this. E to the power of negative x will go this way, and it is cutting at 2. Now some people will be wondering, why is it flowing this way? Now e to the power of negative x is actually 1 over ex, which is 1 over ex. Now 1 over e will be less than 1, so therefore it goes this way. And because I multiply by a 2 in front, it will cut at 2 when x is 0. When x is 0, the answer is 2, therefore it goes this way. Alright, so I want you to take note of that. The last one is here. Okay, I think I've said this before. Okay, it goes this way and it cuts at 2, because this is actually 2, 1 over 3x, as I've said in the previous example. Okay, alright, so let me just double check. 3 negative 1, yes, so this will cut at 2. Okay, so this will be your graphs for the first 6, and I'm going on to the last graph that I have given you for question number 1. Okay, let's look at the last graph which I have given you. Okay, the last graph will look this way. Alright, the last graph will look this way. Okay, and it will cut at 3 on the y-axis. Okay, now the next question I'm giving you is actually question number 4. Okay, you read through the question yourself, and I'm going to explain just the answer. Okay, now when T is given by this, when x is 0, it will represent the initial temperature. When x is 0, because no time has passed yet, therefore x is 0. Okay, so I sub in 0, I will get this as 1. Anything to the power of 0 is 1, so the initial temperature is 90 degrees Celsius. Part 2, 10 minutes. So you sub in x10, you will get this, correct it to 3 significant figures. Okay, now the next part I want to be careful of. It says 1 hour. 1 hour, but x is in minutes. So you have to say that x is 60. Okay, don't plug in 1. 1 means 1 minute. Alright, so you plug in 60 and you will get 26.8 degrees Celsius converted, round off to 3 significant figures. Okay, now I am moving on to question number 6. Okay, question number 6. Okay, let's look at question number 6. Okay, it's on compound interest, okay, and so on and so forth. Now, the amount of money that James invested. Now, when he invested, that means X is 0. That means 0 years has passed. So you plug in 0, you'll get 50,000. This is straightforward. And the amount in the savings account after 5 years, correct to the nearest dollar. So X is 5, you just plug in 5, you get this amount if you round it off to the nearest dollar. Okay, nearest dollar. Okay. Now, so these are straightforward questions. Now, I'm going on to question number 8. Question number 8. Alright. Okay, let's take a look at question number 8. It's over this side here. Okay. Now, they say, on the same axis, sketch the graphs of y equals to 2.5x and y equals to 6 minus x. Now, everybody knows that y equals to 2.5x will go this way, cuts at 1. Now, what is y equals to 6 minus x? Now, this is a line. And for a line, we need at least 2 points to plot. Now, if I sub in 0, I will get 6 for y. If I sub in 6, I'll get 0 for y. So, roughly, the line will go this way. Alright? So, the question says, state the number of solutions to the equation 2.5x equals to 6 minus x. So 2.5x equals to 6 minus x. Now, I want you to know that if we are solving for this equation, we are actually taking the intersection of this graph and this graph. So there's only one point of intersection here. So the question says, state the number of solutions to the equation. They don't want the exact answer, they want the number of solutions. That means how many solutions. So we intersect at one point, so the answer is just one solution. Number of solution is 1. Okay, so that will be your question number 8. Alright, now feel free to pause anytime if you need to take notes. Alright, okay, next question. Question number 11. Sorry, question number 10. Let's look at question number 10. Okay, now question number 10 says, they give you a certain graph and ask you to find the value of A and of B. Now we know that this graph passes through 0, 3 and 1, 6. This is the equation of the graph. Okay, so when x is 0, y is 3. I just plug it in, you will get A equals to 3. Now, once you found A is equal to 3, you put into the equation that you have another point, 1, 6 over here, 1, 6 over there. So you plug in, when x is 1, y is 6, you just plug in, you will get B equals to 2. B equals to 2. So this is a simple case of the equation whereby you just plug in the numbers and you get the answers. Okay, now if you compare question 10 to question 11, question 11 is slightly harder, though they are of the same type. Okay, now question 11 did not give you a graph. So my advice to you is that you go and draw the graph yourself. Okay, you go and draw the graph yourself. Okay, it looks something like that. Then we do the same thing. 2, 2, we plug in 2, 2, 5, 16, we plug in 5, 16. Now you realize that it's quite difficult to solve this. Actually, you have to take division. That means you divide. 2 divided by 1. You get this. You can get rid of A. Then you get your B as 2. B 3, B cubed is 8, so B is 2. You take cube root, so you get 2. Alright. Now, once you get this answer, you'll be plugging the B2 inside equation 1. This is from equation number 1. Then you can get your A as equals to half. A as equals to half. Alright? Okay? So that will be your question 11. Now I'm moving on to question number 12. I'm moving on to question number 12. Okay, now question number 12 says that the population P of fish in a lake T months after a nearby chemical factory commenced operation is given by this amount here. Okay, or rather this equation here. Alright, and we say that find the number of fish in the lake just before the factory started operation. So before it starts operation, T must be 0. We plug in 0. So this whole power becomes 0. So you find the answer as 1800. Okay. Now next, after 1 year. After 1 year is 12 months. So T is 12 here. We plug in, we will get this. Now note that this is again population. Therefore, it hasn't reached 5 yet. So it's 1254. 1254, we round down, just like in the previous example in the last video that I've said. So it's 1254. Alright, 1254. Now the difficult part is actually part 3. Alright, let me explain this. In the long run, that is as T becomes very large. Okay, now I want you to look at this particular equation here. Okay, look at this particular equation here. Now if T becomes very large, okay, when T becomes very large, this thing here will become very small. Okay, all of you try to key in T100. You will see that this becomes a very small value. Okay, when it becomes very small, that means eventually it will approach 0. Okay, that means this value will be approximately 0. Okay, near to 0, but it's never 0. I say tends to 0. Okay, not 0. It becomes very small, but it will never be 0. So e to the power of negative 0.2t will tend to 0. That is, it is very near to 0, but never 0. So what we write is, we write like that. This one means tends to 0. It will become very near to 0, but it will never be 0. So you use an arrow like that. It means tends to 0. Okay? So if t were to if this whole value is 10 to 0, if you look at this, if this one is approximately 0, this whole thing will only be 2, because 2 plus 0 is 2. Okay, so 600 times 2 is 1200. So if time becomes very large, that means as time goes on, the population will be approaching 1200. So this is what it means. Okay, now I want you to take some time to think about what I'm saying here. What I'm saying here is that this particular value will be approximately going to 0. Okay, so this one will approximately go to 600 times 2, because this is approximately 0. So that's why we get the answer of 1200 fishes in that particular lake. Alright, so this is your example number 12. Okay, if you need to pause and think about it, please do so. Now the next question, question 14. Question 14 talks about radioactivity. Okay, now the mass m grams of a radioactive substance present T days after it was first observed is given by this. Okay, now find the initial mass of this polonium. So when T is 0, you get, so initial mass is 10 grams. Now next, find the remaining mass of the thing after 30 days. Okay, after 30 days, that means when T is 30, I will get this, and I round it off to 3 significant figure, T30, plug in, get this answer, 8.62 grams. Now part 3. Hence, find the mass of substance that has decayed. Now don't forget, this is the amount, the question define it as this is the amount that is present. Okay, that is present. So the amount that is present is given by this. So this is the amount present. So the amount decayed, you get the initial amount minus this. So you will get a 1.38 grams that has already decayed. Alright, I hope this is clear. Question 14. Alright, next one will be question 16. Okay, now let's look at question 16. An object is heated in an oven until it reaches X degrees Celsius. It is then allowed to cool. Its temperature theta after it has cooled for T minutes is given by this formula here. This one. Okay. Part 1. Find the value of X. Okay, find the value of X. X means the initial temperature. That means when T is 0, what is theta? So you plug in 0 here, you will get 120 degrees Celsius. Okay, 120 degrees Celsius. Part 2. The value of theta when T is 8. This is simple. Just plug in 8 and round it off to 3 sig fig. You will get the answer. 94.3 degrees Celsius. Okay. Now, part 3. The value of T when theta is 84. Now, when theta is 84, I just plug into this equation. So, 84 is this. Now, I move the 20 over, minus 20 becomes 64. Okay, 100 move over becomes 0.64. Now, I change to the same base. Once it is the same base, I can equate the powers. So, T over 6 equals to 2. T will be equals to 12. So, that's how I get my value of T. Okay, now part 4. Part 4 is actually similar to 12 part 3. The value of theta, the value that theta approaches as T becomes very large. Now I want to look at this particular equation. Okay, look at this particular equation here. Alright, now if T becomes very large, okay, look here. If T becomes very large, can you key in T equals to 500? You will realize that this one goes to 0. This one goes to 0. Tends to 0, not goes to 0. Tends to 0. So, theta equals to 20 plus 100 to something that is very close to 0. Okay? Now, if 100 times something is very close to 0, it is still close to 0. So, theta will just be equals to 20. This is how I do the next part here. Okay? Alright? So, I will get the answer as if it's 100 times something very small, this one will also be very small. Okay, so it tends to 20. So, when T becomes very large, theta will be 20 degrees Celsius. Now, I want to give you the physical meaning of what is this 20 degrees Celsius. Now, if you put the object that's heated in an oven on a table for a very long time, actually it will approach the room temperature. So therefore, 20 degrees Celsius is actually the room temperature. Okay, so I want you to know the physical meaning of this particular question. Okay, so class, I have already gone through all the questions that I've assigned for exercise 5.2, and can you please take down the answers and make sure you rectify your mistakes. Okay, thank you very much. Have a good day.